Space is a liar, not because it deceives us, but because it shows us things so strange, so impossible, that our first instinct is disbelief. Imagine a world where glass rains sideways at thousands of kilometers per hour, slicing through the sky like crystal daggers. Imagine a planet so dense it could fit into the palm of your hand and outweigh entire mountains. Imagine stars that sing, galaxies that eat one another, black holes that slow time to a crawl. All of it real. All of it happening right now, above our heads. For most of history, humans looked up at the night sky and thought they understood it. Stars seemed eternal, pinpricks of light fixed in the heavens. Planets wandered in graceful arcs, predictable and familiar. The cosmos appeared calm, steady, comprehensible. But science has stripped away that illusion. With telescopes that see farther, detectors that listen deeper, and theories that probe stranger, we've discovered a universe more bizarre than myth, more alien than imagination, more unbelievable than fiction. And yet, it is real. The universe does not care if we believe it or not. It simply is vast, chaotic, mysterious. A place where diamonds fall as rain, where stars collapse into spheres smaller than a city yet heavier than the sun, where invisible matter outweighs everything we can see. These are not fantasies. They are facts, confirmed by observation, etched into equations, measured in data. Still, they feel impossible. They sound fake. They defy our sense of reality, because reality itself is far stranger than the world we evolved to understand. And that is the gift of space, to humble us, to shock us, to remind us that we know almost nothing, and that what little we do know is enough to leave us breathless. This is the story of a universe that laughs at expectation, a universe that rains fire and glass, bends time and light, builds skeletons of invisible matter, and sings in voices we cannot hear. This is the story of space facts that sound fake, but are totally real. Worlds of fire and glass. The universe is not generous with comfort. Beyond the fragile shell of our atmosphere, beyond the thin ribbon of warmth that makes Earth livable, lie worlds so alien that even the strangest landscapes of science fiction pale beside them. Exoplanets, worlds orbiting distant stars, have revealed themselves in staggering variety. Some are scorched, some frozen, some cloaked in storms that never end. They are not the gentle spheres of imagination, but places of fire and glass. Places where the laws of physics twist landscapes into nightmare. To know them is to realize that Earth is not ordinary. Earth is rare. One of the first of these strange worlds discovered was 55 Cancri, a planet orbiting a star only 40 light-years away. At first glance, it is simply a super-Earth, larger than our world, but not as massive as a gas giant. Yet its nature defies comprehension. Its surface broils at over 2,000 degrees Celsius, hot enough to melt iron. Half of it is locked in eternal day, facing its star in a blistering glare. The other half languishes in endless night, frozen in shadow. But its strangest secret may lie beneath its crust. Models suggest that much of this planet could be made of carbon, compressed by heat and gravity into crystalline form. If so, then 55 Cancri may be a diamond planet, an entire world glittering with the hardest gemstone known, an alien sphere of unimaginable wealth and beauty. A planet of diamonds sounds like myth, like fantasy, and yet it is real. More brutal still is HD 1-89733b, a gas giant circling a star 63 light-years away. To approach it is to enter a furnace. Its atmosphere is heated to over 1,000 degrees Celsius, boiling with violent winds. These winds scream at speeds of 7,000 kilometers per hour, nearly 10 times the speed of sound. And within them falls a rain, unlike anything on Earth. Tiny particles of silicate glass are swept into the air, scattering blue light, making the entire planet appear sapphire from afar. But this beauty is lethal. The winds carry shards of glass sideways across the skies, an eternal storm of razor crystal cutting through its atmosphere. A world where it rains, glass sounds absurd, yet there it is, shining blue against the blackness of space. Nor are these exceptions. Exoplanet catalogs now brim with worlds stranger still. WASP-12, Bee's orbits so close to its star that it is stretched into the shape of an egg, its very body distorted by gravity. The star's heat tears at its atmosphere, drawing it away into space, devouring the planet in a slow-motion apocalypse. Scientists call it a hot Jupiter, but names cannot convey its reality. A world that is dying, its atmosphere streaming into its star like smoke into flame. Another, KELT 9b, endures temperatures hotter than most stars, a gas giant where molecules themselves are ripped apart by heat. Its surface would vaporize iron, its skies a haze of dissociated atoms. It is not a planet in the way we understand planets. It is a furnace masquerading as a world. Some planets defy not just our comfort, but our imagination. Take Tris 2b, a gas giant discovered in 2011. Its atmosphere is so dark, it reflects less than 1% of the light that touches it. Seen from space, it would appear not as a glowing sphere, but as a hole, a patch of nothingness orbiting its star. It is blacker than coal, darker than paint, a world that swallows light itself. How can such a thing exist? And yet, it does. Others spin their illusions in rhythm and dance. Kepler 16b, for instance, orbits not one star, but two. To stand upon its surface would be to see twin suns rising and setting in tandem, a horizon painted with double shadows. Science fiction imagined such worlds long ago, Tatooine in Star Wars. But here it is, a real planet orbiting real stars. A place where sunsets are doubled and reality is stranger than film. The mammoth catalog of the Kepler Space Telescope has shown us that the universe is a factory of the bizarre. Planets locked to their stars, so one side burns in endless day, while the other freezes in eternal night. Planets made of gas so thin they would float in water. Planets that wander the void with no star at all. Rogue worlds drifting through interstellar dark, frozen giants alone in the abyss. Each discovery reminds us that Earth is not the template but the exception. Our world is temperate, balanced, habitable, but it is rare. Most planets are brutal. They are furnaces, glaciers, storm worlds, shadows, diamonds, illusions. They defy our sense of what a planet is, teaching us that the universe does not conform to our expectations. And perhaps that is their greatest gift. To look upon a world of glass rain or diamond crust is not simply to marvel at its strangeness. It is to realize that possibility is larger than imagination. The universe is not only stranger than we suppose, it is stranger than we can suppose. Every time we think we have exhausted its tricks, it reveals another world, another fact that sounds fake, another truth that forces us to expand the boundaries of what we believe reality can hold. In the end, these planets are not fictions, but reminders. Reminders that the cosmos is a vast laboratory of extremes, a place where nature experiments endlessly with form and physics. And we, Brief creatures of a gentle earth are its witnesses, its students, its astonished chroniclers. The worlds of fire and glass may kill us if we ever set foot upon them, but from afar, they teach us something vital, that reality is never confined to the familiar, and that in the infinite expanse of space, the impossible is often the most real of all. Stars that shouldn't exist. The night sky seems timeless. To the naked eye, stars appear serene, distant fires glowing steadily, eternal in their beauty. But the truth is far stranger. Stars are not eternal. They are not serene. They are engines of physics pushed to their limits, experiments in gravity and nuclear fusion, bodies so extreme that some should not exist at all, and yet they do. The universe has forged stars that bend our sense of possibility, objects so dense, so powerful, so alien that even the wildest imaginations struggle to contain them. Consider the neutron star. Born in the aftermath of a supernova, it is what remains when a massive star exhausts its fuel and collapses under its own gravity. The core implodes. Electrons and protons crush together into neutrons, forming a sphere no larger than a city. Yet this tiny remnant contains more mass than our sun. A teaspoon of neutron star material would outweigh mountains. Its gravity is so intense that if you stood on its surface, impossible though that is, you would be flattened instantly, your body compressed into atoms, your atoms into fragments smaller still. It is a star reduced to pure density, an object that should not be possible. And yet the night sky is littered with them, hidden in the dark, spinning like lighthouses of death. Some neutron stars spin so fast that they flash beams of radiation toward us, sweeping the cosmos like cosmic beacons. These are pulsars, and their rotations defy comprehension. Some turn hundreds of times every second, entire stars spinning faster than a kitchen blender. Their timing is so precise that they rival atomic clocks, their pulses steady enough to navigate spacecraft. And yet they are not mechanical, not artificial. They are dead stars, corpses of giants, spinning endlessly in the void. Stranger still are magnetars, neutron stars with magnetic fields so strong they defy comprehension. Their magnetism is trillions of times stronger than Earth's, enough to warp atoms, enough to erase credit cards from halfway across the moon. A single magnetar eruption releases more energy in a fraction of a second than our sun emits in 100,000 years. These explosions ripple through space, detectable across the galaxy. They are stars in agony, twitching with stresses beyond physics, their crusts cracking under forces we cannot imagine. And then there are the hypergiants, stars so massive they should tear themselves apart, yet somehow hold together. Eta Carinae, for example, is a star 100 times more massive than our sun, luminous enough to outshine millions of stars combined. It is unstable, on the edge of collapse, surrounded by a nebula of gas it has already shed in violent eruptions. When it dies, it may explode as a hypernova, an explosion so vast it could sterilize space for light years around. The fact that such a star exists at all is improbable. The fact that it endures is miraculous. Some stars even orbit black holes, dancing on the edge of oblivion. Their gas is pulled away, spiraling into accretion disks, glowing hotter than any furnace. These binary systems blur the line between life and death. Stars cannibalized by companions that are no longer stars at all. They should not persist, and yet the cosmos is full of them, fiery and doomed, beauty entwined with destruction. Perhaps the strangest stars are those made not of normal matter, but of possibility. Some scientists speculate that in the earliest moments of the universe, before atoms even formed, there may have been stars made of dark matter. These dark stars would not shine with fusion, but with annihilation, glowing from the energy of particles colliding. They may have been vast, bloated, and alien, illuminating the newborn cosmos with light unlike anything we know. Whether they existed or not, their possibility stretches our understanding of what a star could be. Even the familiar sun carries strangeness within it. Its surface, roiling with plasma, belches storms that fling radiation across space. Its interior is a furnace where hydrogen becomes helium, releasing energy that sustains life. Yet even the sun will one day exhaust its fuel, swell into a red giant, and consume the inner planets. Stars are not timeless. They are stories written in light and death, each one a fusion engine racing against its own collapse. To say stars shouldn't exist is to admit our ignorance. They exist because physics allows them, because gravity and pressure find balances we did not expect. They are reminders that the universe is not bound by our intuition. It creates pulsars that spin like toys, magnetars that bend atoms, giants that blaze with impossible brightness. Each of them sounds fake. Each of them is real. And so the night sky, serene to the eye, is in truth a gallery of impossibility. Each point of light is a question. Each star is a miracle of survival, of collapse, of balance on the edge of physics. To look up is to see not serenity, but strangeness, not permanence, but transformation. Stars that should not exist, existing all the same, burning their impossible fires against the void. Cosmic behemoths. The universe is not modest. It builds on scales so vast, so outrageous, that the numbers collapse under their own weight. Galaxies stretching for hundreds of thousands of light years, black holes weighing billions of suns, jets of energy longer than galaxies themselves. These are the cosmic behemoths, monsters of gravity and light, engines of creation and destruction. They are so extreme that they sound impossible, inventions of fevered imagination. And yet they are real, woven into the architecture of the cosmos itself. Begin with the black hole, the most infamous of them all. A black hole is the corpse of a massive star, collapsed so completely that nothing can escape its gravity. Not light, not matter, not even time itself. To fall into one is to fall beyond knowing, to pass an event horizon where physics breaks down. To speak of them at all is to step into paradox, into places where reality folds in ways we cannot yet describe. And yet, black holes are not rare. They populate galaxies by the millions, hiding in darkness, revealing themselves only when they feed, ripping gas from stars, heating it until it glows with X-rays before swallowing it whole. But black holes come in sizes that defy imagination. Some are only a few times the mass of our sun. Others, the supermassive black holes, weigh billions of suns. At the center of our own Milky Way lies Sagittarius, a star, a black hole 4 million times heavier than our star. And yet, compared to others, it is small. In the galaxy, M is painted with double shadows. Science fiction imagined such worlds long ago. Tatooine in Star Wars. But here it is, a real planet orbiting real stars. A place where sunsets are doubled and reality is stranger than film. The mammoth catalog of the Kepler Space Telescope has shown us that the universe is a factory of the bizarre. Planets lock to their stars, so one side burns in endless day, while the other freezes in eternal night. Planets made of gas so thin they would float in water. Planets that wander the void with no star at all. Rogue worlds drifting through interstellar dark, frozen giants alone in the abyss. Each discovery reminds us that Earth is not the template but the exception. Our world is temperate, balanced, habitable, but it is rare. Most planets are brutal. They are furnaces, glaciers, storm worlds, shadows, diamonds, illusions. They defy our sense of what a planet is, teaching us that the universe does not conform to our expectations. And perhaps that is their greatest gift. To look upon a world of glass rain or diamond crust is not simply to marvel at its strangeness. It is to realize that possibility is larger than imagination. The universe is not only stranger than we suppose, it is stranger than we can suppose. Every time we think we have exhausted its tricks, it reveals another world, another fact that sounds fake, another truth that forces us to expand the boundaries of what we believe reality can hold. In the end, these planets are not fictions, but reminders. Reminders that the cosmos is a vast laboratory of extremes, a place where nature experiments endlessly with form and physics. And we, brief creatures of a gentle earth, are its witnesses, its students, its astonished chroniclers. The worlds of fire and glass may kill us if we ever set foot upon them, but from afar, they teach us something vital. That reality is never confined to the familiar, and that in the infinite expanse of space, the impossible is often the most real of all. Stars that shouldn't exist. The night sky seems timeless, but the truth is far stranger. Stars are not eternal. They are not serene. They are engines of physics pushed to their limits, experiments in gravity and nuclear fusion, bodies so extreme that some should not exist at all, and yet they do. The universe has forged stars that bend our sense of possibility, objects so dense, so powerful, so alien that even the wildest imaginations struggle to contain them. Consider the neutron star. Born in the aftermath of a supernova, it is what remains when a massive star exhausts its fuel and collapses under its own gravity. The core implodes. Electrons and protons crush together into neutrons, forming a sphere no larger than a city. Yet this tiny remnant contains more mass than our sun. A teaspoon of neutron star material would outweigh mountains. Its gravity is so intense that if you stood on its surface, impossible though that is, you would be flattened instantly, your body compressed into atoms, your atoms into fragments smaller still. It is a star reduced to pure density, an object that should not be possible. And yet the night sky is littered with them, hidden in the dark, spinning like lighthouses of death. Some neutron stars spin so fast that they flash beams of radiation toward us, sweeping the cosmos like cosmic beacons. These are pulsars, and their rotations defy comprehension. Some turn hundreds of times every second, entire stars spinning faster than a kitchen blender. Their timing is so precise that they rival atomic clocks, their pulses steady enough to navigate spacecraft. And yet they are not mechanical, not artificial. They are dead stars, corpses of giants, spinning endlessly in the void. Stranger still are magnetars, neutron stars with magnetic fields so strong they defy comprehension. Their magnetism is trillions of times stronger than Earth's, enough to warp atoms, enough to erase credit cards from halfway across the moon. A single magnetar eruption releases more energy in a fraction of a second than our sun emits in 100,000 years. These explosions ripple through space, detectable across the galaxy. They are stars in agony, twitching with stresses beyond physics, their crusts cracking under forces we cannot imagine. And then there are the hypergiants, stars so massive they should tear themselves apart, yet somehow hold together. Eta Carinae, for example, is a star 100 times more massive than our Sun, luminous enough to outshine millions of stars combined. It is unstable, on the edge of collapse, surrounded by a nebula of gas it has already shed in violent eruptions. When it dies, it may explode as a hypernova, an explosion so vast it could sterilize space for light years around. The fact that such a star exists at all is improbable. The fact that it endures is miraculous. Some stars even orbit black holes, dancing on the edge of oblivion. Their gas is pulled away, spiraling into accretion disks, glowing hotter than any furnace. These binary systems blur the line between life and death. Stars cannibalized by companions that are no longer stars at all. They should not persist, and yet the cosmos is full of them, fiery and doomed, beauty entwined with destruction. Perhaps the strangest stars are those made not of normal matter, but of possibility. Some scientists speculate that in the earliest moments of the universe, before atoms even formed, there may have been stars made of dark matter. These dark stars would not shine with fusion, but with annihilation, glowing from the energy of particles colliding. They may have been vast, bloated, and alien, illuminating the newborn cosmos with light unlike anything we know. Whether they existed or not, their possibility stretches our understanding of what a star could be. Even the familiar sun carries strangeness within it. Its surface, roiling with plasma, belches storms that fling radiation across space. Its interior is a furnace where hydrogen becomes helium, releasing energy that sustains life. Yet even the sun will one day exhaust its fuel, swell into a red giant, and consume the inner planets. Stars are not timeless. They are stories written in light and death, each one a fusion engine racing against its own collapse. To say stars shouldn't exist is to admit our ignorance. They exist because physics allows them, because gravity and pressure find balances we did not expect. They are reminders that the universe is not bound by our intuition. It creates pulsars that spin like toys, magnetars that bend atoms, giants that blaze with impossible brightness. Each of them sounds fake. Each of them is real. And so the night sky, serene to the eye, is in truth a gallery of impossibility. Each point of light is a question. Each star is a miracle of survival, of collapse, of balance on the edge of physics. To look up is to see not serenity, but strangeness, not permanence, but transformation. Stars that should not exist, existing all the same, burning their impossible fires against the void. Cosmic behemoths. The universe is not modest. It builds on scales so vast, so outrageous, that the numbers collapse under their own weight. Galaxies stretching for hundreds of thousands of light years, black holes weighing billions of suns, jets of energy longer than galaxies themselves. These are the cosmic behemoths, monsters of gravity and light, engines of creation and destruction. They are so extreme that they sound impossible, inventions of fevered imagination. And yet they are real, woven into the architecture of the cosmos itself. Begin with the black hole, the most infamous of them all. A black hole is the corpse of a massive star, collapsed so completely that nothing can escape its gravity. Not light, not matter, not even time itself. To fall into one is to fall beyond knowing, to pass an event horizon where physics breaks down. To speak of them at all is to step into paradox, into places where reality folds in ways we cannot yet describe. And yet, black holes are not rare. They populate galaxies by the millions, hiding in darkness, revealing themselves only when they feed, ripping gas from stars, heating it until it glows with X-rays before swallowing it whole. But black holes come in sizes that defy imagination. Some are only a few times the mass of our sun. Others, the supermassive black holes, weigh billions of suns. At the center of our own Milky Way lies Sagittarius, a star, a black hole 4 million times heavier than our star, so vast it defies belief. 6.5 billion solar masses, its event horizon larger than our entire solar system. The first image of it, captured in 2019, was a blurred ring of fire, a shadow against infinity, the portrait of an abyss. To imagine such an object is difficult enough. To realize it exists is staggering. These black holes do not merely consume, they create. As matter spirals toward them, it forms accretion disks, whirling faster and hotter than anything in the universe. Magnetic fields twist, and from the poles of these disks erupt jets of energy, beams that stretch for thousands, even millions of light years. These relativistic jets pierce galaxies, illuminating intergalactic space, visible across cosmic distances. They are powered by the hunger of gravity itself, by the fall of matter into the abyss. They sound like fantasy, fountains of light shooting from nothingness. But they are among the brightest phenomena in the universe. Some black holes grow even stranger, powering quasars, the blazing hearts of young galaxies. Quasars are so luminous that they can outshine their entire host galaxy, pouring out more light than trillions of stars combined. And they do so not for moments, but for millions of years, beacons blazing in the dark of the early universe. To see one is to look back billions of years, to glimpse galaxies when they were young and wild, their black holes ravenous, their jets cutting through the cosmos like searchlights. These objects should not exist. Galaxies lit brighter than imagination, and yet the universe is filled with them. And then there are the truly monstrous black holes, so large they almost break language. Ultramassive black holes, tipping the scales at tens of billions of suns, perhaps even more. Some estimates suggest a few could reach 100 billion solar masses, their event horizons stretching across entire star systems. These are not just objects. They are realms, gravitational empires into which entire solar systems could vanish. To call them holes seems laughably insufficient. They are abysses stitched into the fabric of space-time itself. But the behemoths of the universe are not only black holes. Galaxies themselves are monsters of scale. The Milky Way, vast though it is only average. Other galaxies dwarf it. Andromeda, stretching 200,000 light-years. IC 1101, a giant elliptical over 4 million light-years across, home to trillions of stars. To fly across it at the speed of light would take longer than humans have existed. These are not mere smudges in the sky, but empires of stars, clusters of suns by the trillion, bound together by dark matter and the gravity of their central black holes. Beyond galaxies lie clusters, gatherings of hundreds or thousands of galaxies bound together, swimming in halos of dark matter, connected by filaments of the cosmic web. Some span tens of millions of light-years, their combined mass so great it warps space-time. bending light from galaxies behind them, creating mirages of the universe. These gravitational lenses allow us to see farther, to glimpse objects otherwise invisible, turning clusters into cosmic telescopes. Their existence sounds like magic, galaxies magnifying galaxies. But it is physics at its most elegant, the bending of light by mass. And then there are the superclusters, the largest structures we know. Our own galaxy belongs to one, the Laniakea supercluster, a vast basin of attraction drawing together 100,000 galaxies across 500 million light years. Even larger are the Sloan Great Wall and the Hercules Corona Borealis Great Wall, structures so vast they stretch across billions of light years. These are cosmic behemoths, not of stars or black holes, but of structure itself, skeletons of the universe drawn in galaxies and voids. They are so immense that to call them objects feels absurd. They are continents of the cosmos, walls of creation sprawling across space-time. Each of these behemoths, black holes, quasars, galaxies, clusters, superclusters, is an affront to intuition. They are too large, too bright, too powerful, too strange. They sound fake. They sound impossible. And yet, they are real. Revealed by telescopes, confirmed by equations, etched into the night sky. And perhaps the strangest truth of all is this: we are part of them. Our galaxy orbits the center of a supercluster. Our stars are shaped by the pull of dark matter. Even our existence, fragile and brief, unfolds in the shadow of a black hole 4 million times the mass of our sun. The behemoths are not distant curiosities. They are our context, our neighborhood, our home. To confront them is to confront our own smallness, but also our belonging. We are not separate from the monsters of the cosmos. We are threads in their vast tapestry, sparks of awareness flickering in their gravitational fields. They are not only behemoths, they are mirrors, showing us that the universe is larger, stranger, and more astonishing than we can ever fully grasp. Impossible orbits. When we look at the planets of our solar system, we imagine their order as natural, inevitable, small rocky worlds close to the sun, giants of gas farther out, icy dwarfs at the edge. It seems logical, stable, balanced, the way planets should be. But the universe has no obligation to follow our patterns. Beyond our skies, orbiting other stars, lie worlds whose motions seem absurd, orbits so extreme they challenge what we thought planets could endure. These are the impossible orbits, rogue wanderers, hot giants skimming their stars, and worlds that dance to the gravity of more than one sun. They sound fake, the inventions of fiction, and yet they are real. Consider first the hot Jupiters. When astronomers began to detect exoplanets, they expected to find worlds like ours, rocky planets close in, giants farther out. Instead, they found monsters, gigantic gas planets, as large as or larger than Jupiter, orbiting so close to their stars that their years lasted only days. Some circle their stars in less than a week, their atmospheres heated to thousands of degrees, their clouds boiling into space. These orbits should not exist, yet they do. It was 51 Pegasi b, the first of these discovered, that shattered our assumptions. A world half the mass of Jupiter, circling its star every 4 days, blistering under heat. To find such a world was like finding a furnace in the heart of a garden. It defied everything models predicted. And yet, in the years since, we have found hundreds more. The strangest truth is that some of these hot Jupiters may not have formed where they orbit now. They may have formed farther out, like our own Jupiter, and then migrated inward, spiraling closer and closer until they nearly brush the faces of their stars. The thought of a world so massive, so heavy, moving inward through a planetary system, destabilizing everything in its path, is astonishing. Imagine if Jupiter had plunged toward our Sun. Earth and its siblings would have been flung into chaos, scattered into space, or consumed. And yet, around other stars, this chaos has been reality. Other orbits defy imagination in different ways. Some planets orbit not one star, but two stars, locked in a dance of gravity so precise it remains stable across ages. To stand there would be to see twin shadows stretching across the ground, to live in a world of double warmth, double night, double wonder. Fiction imagined it in Tatooine, but the universe delivered reality. Some worlds orbit stars so eccentric that their paths stretch like ovals across space. HD 80606b is one such world. Its orbit is so elongated that for most of its year it drifts far from its star, frozen and cold. Then, in a brief swing, it plunges close, heating by hundreds of degrees in hours, its atmosphere boiling, storms raging, a planet whipped between fire and ice every orbit. To imagine weather on such a world is almost absurd, and yet it exists. Planets without stars. These rogue planets drift through the galaxy, cast off from their systems, wandering in darkness. Some may have formed around stars and been ejected by gravitational chaos. Others may have formed directly in the void, clumps of gas and dust collapsing in isolation. To float through interstellar space without a sun to warm you seems impossible, yet there may be more rogue planets in the galaxy than stars. Entire worlds adrift, their skies black, their surfaces frozen, their solitude eternal. And yet, even here, life may not be impossible. A rogue planet with a thick atmosphere and geothermal heat could harbor oceans beneath its ice, hidden sanctuaries in a cosmos of cold. Impossible orbits also exist close to destruction. Some worlds circle so near their stars that they dance between stars, drift in darkness. The universe is not orderly. It is creative, chaotic, experimental. It tries every configuration, tests every boundary, produces every impossibility. And as we watch these orbits unfold, we are reminded of our own fragility. Earth is stable, for now. Its orbit is circular, its distance from the sun perfect for liquid water and life. But it might not have been. A slight change, a wandering giant, a rogue encounter, and Earth could have been thrown outward into frozen exile or inward into fire. Our existence depends on stability, and stability is rare. The impossible orbits of distant worlds sound fake. They sound like invention, yet they are real, and they teach us humility. They show us that the universe is not bound by our expectations, that planets can circle two suns, or none, or fall so close to their stars that they melt. They remind us that Earth is not inevitable. It is improbable. It is miraculous. And to know that is to see our world not as ordinary, but as extraordinary, fragile, and precious in the endless storm. Seconds tick, minutes pass, hours accumulate. The rhythm of a clock feels absolute, the flow of time constant everywhere. But in the universe, time is not steady. It bends, stretches, warps. It quickens and slows. Time, which we think of as unchanging, is as malleable as space, as dynamic as light. It is an illusion of permanence in a cosmos where nothing is permanent. And the strangest fact is this: what we call now is not the same for everyone, not the same everywhere. Time itself is relative. Albert Einstein revealed this unsettling truth over a century ago. His theory of relativity showed that space and time are woven together into a single fabric, space-time. Gravity is not merely a force pulling objects together, but a warping of this fabric. Massive bodies like stars and planets bend space-time around them, and everything, including time itself, follows those curves. The result is a cosmos where clocks do not agree, where the passage of time depends on speed and gravity. Consider the twin paradox, a thought experiment that sounds fake but is real. Imagine twins. One remains on Earth, the other boards a spacecraft and travels near the speed of light. For the traveler, time slows. The years pass, but more slowly than for the sibling left behind. When the traveler returns, they are younger, while their twin has aged. This is not fantasy. This is time dilation, proven by experiments with high-speed particles and confirmed by astronauts. Even the GPS satellites that orbit Earth must adjust for time dilation. Their clocks corrected daily to keep our navigation precise. Time ticks differently in space than it does on Earth. The effect grows stranger near massive objects. A black hole, for instance, bends space-time so severely that time slows dramatically near its horizon. An observer falling toward it would experience time normally, but to someone watching from afar, their descent would appear to freeze, stretched into eternity. From outside, they never cross the horizon. From inside, they cross it in a moment, never to return. Both views are true. Time itself disagrees. Even on Earth, gravity alters time. A clock on a mountain runs slightly faster than one at sea level because it is farther from Earth's center of gravity. The difference is tiny, nanoseconds, but measurable. Time is not universal. It is local, flowing differently depending on where you stand. We live in a universe where when is not absolute but contextual. At cosmic scales, this truth grows even stranger. Light from distant galaxies takes billions of years to reach us. We see them not as they are, but as they were. The night sky is not a view of the present, but a museum of the past. Photons carrying ancient images across time. When we look into space, we look into history. The farther we see, the older the light. Some galaxies we observe may already be gone, their stars extinguished, their forms dissolved, yet their light still journeys toward us. To look at the night sky is to look into ghosts. And in the most extreme places, time can be stretched almost to breaking. Near the edge of a black hole, minutes can become centuries relative to the outside universe. Science fiction captured this idea in Interstellar, when astronauts on a planet near a black hole experience hours, while years pass for their colleagues in orbit. A single event unfolding with different durations depending on where you stand. This truth has unsettling implications. If time is relative, then simultaneity, the idea of a single universal now, does not exist. Events that seem simultaneous to one observer may not be simultaneous to another. The cosmos has no single present moment, only overlapping perspectives. Our notion of time as linear, universal, and absolute is an illusion born of living on a small, stable world where differences are imperceptible. Step into the wider universe, and that illusion crumbles. Even the future of time is uncertain. Some cosmologists suggest that time itself may emerge from deeper physics, that it is not fundamental but emergent, like temperature arising from the motion of particles. Others explore the possibility that time may one day cease, that in the deep future, the universe may fall into a state where change itself ends, leaving only stillness. These ideas sound fake. They sound like philosophy. And yet, they are grounded in equations, in theories that strive to explain the deepest workings of reality. For us, bound to our fleeting lifespans, time is the measure of everything. It gives us past, present, and future. It frames our memories, our choices, our hopes. Yet in the cosmos, it is flexible, unreliable, strange. A universe where time itself bends is a universe that defies into, but it is our universe, and we are its children. Perhaps that is why the illusion of time feels so strong. Our minds evolved to trust rhythm, to see seconds as constant, to believe in now as a shared reality. It is a useful fiction, one that allows us to live, to think, to plan. But the deeper we look, the more that fiction dissolves. Time is not a river flowing steadily forward. It is a landscape, bent and warped, different for every traveler. And so, in the end, the most unsettling truth of all may be this: there is no single answer to the question, what time is it? The universe has no clock. There is no universal now. There is only relativity, only perspective, only the strange truth that time itself, the one thing we thought we could trust, is as slippery and strange as the stars. Galaxies in collision. When we look at the night sky, the stars seem serene, fixed in their constellations, the galaxies like quiet swirls of light pinned against the darkness. But the truth is far more dramatic. Galaxies are not static. They move. The universe is a restless sea, and galaxies are its ships, bound to meet, to merge, to tear one another apart in tidal chaos. Collisions of such scale sound fake, like the imagined violence of fiction. Yet they are real. They have happened countless times, and one day they will happen to us. The first shock is this: galaxies collide not rarely, but often. In the vast history of the cosmos, collisions are inevitable. Gravity draws galaxies toward one another, pulling at their halos of dark matter, tugging at their stars, warping their shapes. When they meet, they do not pass quietly. They twist into spirals, stretch into tails, fling stars across intergalactic space. Entire systems are restructured in the slow ballet of gravity. It is violence measured not in seconds, but in millions of years. Andromeda, our nearest large neighbor, is rushing toward us even now. 2 million light years away, its stars blaze in silence, but its motion is real, its trajectory fixed. In 4 billion years, it will collide with the Milky Way. From afar, the event would be spectacular. Two galaxies drawn together, their spiral arms distorting, their stars flung outward in tidal streams, their black holes spiraling inward, eventually merging into a single monster. From within, the view will be even stranger. Stars will appear to drift in new patterns. Nebulae will stretch into ribbons. The night sky will blossom with strange, impossible shapes. And yet, for all this, the likelihood of stars colliding directly is almost zero. The distances between them are too vast. Instead, the galaxies will merge their structures, their dark matter halos blending, their black holes consuming one another. The stars will survive, but their home will be forever changed. Already we see such collisions across the universe. Telescopes reveal galaxies in mid-embrace, their arms warped into arcs of light, their centers glowing with the heat of newborn stars. When galaxies collide, gas clouds compress, triggering bursts of star formation. These starburst galaxies burn furiously, birthing suns at rates hundreds of times greater than normal. From the chaos of collision emerges creation, new stars lighting the dark, Collisions are not only destruction, they are renewal. The antennae galaxies, for instance, are locked in a cosmic dance 45 million light years away. Their spirals stretch into long tidal tails, streams of stars flung outward like sparks. In their hearts, new stars blaze, clusters forming in the dense knots of gas. In time, the antennae will settle into a single, larger galaxy. What looks like violence is, in truth, transformation. The universe builds with the same hand it destroys. Even larger collisions shape the fate of clusters. The bullet cluster, a famous example, reveals the aftermath of two galaxy clusters colliding. Its hot gas clouds crashed together, creating shock waves visible in X-rays. But the galaxies themselves passed through relatively unscathed, their stars too small and distant to interact. The dark matter, invisible but measurable through gravitational lensing, slid through as well, separating from the gas. It is collisions like this that give us some of the best evidence for dark matter, showing us its presence through the way it behaves differently from normal matter. A violent clash becomes not just spectacle, but revelation. Some collisions trigger even more astonishing phenomena. When two supermassive black holes spiral together at the heart of merging galaxies, they emit ripples in space-time, gravitational waves. We have already detected these waves from smaller black holes, but in the future, instruments may capture the merging of galactic giants. The universe itself will tremble, space-time quivering with the energy of unimaginable masses colliding. That this is real, that space itself can ripple, sounds like invention, but it is fact, measured and confirmed. Galaxies in collision also remind us of impermanence. The spiral forms we see, so graceful, are temporary. Spirals are easily disturbed, their arms stretched and warped by gravitational tugs. Over billions of years, collisions transform spirals into ellipticals, great ovals of stars without pattern, the fossils of countless mergers. The universe we see today is shaped by this endless dance. Every galaxy bears scars of its past, every cluster a record of encounters written in the shapes of stars. And what of us, here on Earth, inside the Milky Way? When Andromeda arrives, our galaxy will not survive intact. Its spiral arms will dissolve. Its stars will be flung outward. Its black hole will merge with Andromeda's. A new galaxy will form, Milkomeda, or perhaps the Milkdromeda, a vast elliptical in place of two spirals. Earth may still orbit the sun, unscathed by direct collision, but the night sky will never be the same. Imagine looking up to see the arc of Andromeda stretching across the heavens, its stars mingling with our own. Imagine a sky alive with change, galaxies colliding above us, a reminder that even the stars are not eternal. Collisions of galaxies sound fake because they play out on scales beyond our grasp. Millions of light years, billions of stars, timescales longer than life, longer than civilization, longer than memory. But they are real. They are the architects of the universe, the shapers of galaxies, the sculptors of the night sky. And perhaps the strangest fact of all is that without them, we would not exist. Our Milky Way is a child of collisions, its history written in mergers with smaller galaxies. Our Sun, our Earth, our lives may be the products of starbursts triggered by ancient encounters. The violence of galaxies colliding gave birth to the calm of our world. What sounds like destruction is, in truth, creation. The impossible fact is that we live because galaxies collide. The universe is restless. The galaxies drift. The collisions will continue. And in their endless dance, the cosmos reminds us that even the most serene lights in the night sky are part of a story of motion, chaos, and transformation. A story that sounds fake, but is, and always will be, real. The sound of space. The first thing we are told about space is that it is silent. A vacuum cannot carry sound. No air, no medium, no vibration of molecules to move waves from one place to another. In space, they say, no one can hear you scream. And yet this is only half true, for the cosmos does sing, in voices stranger than any we know. Not with sound waves in air, but with vibrations in plasma, with ripples in space-time, with frequencies that lie beyond human hearing. Space has a sound, not silence, but symphony. Consider the sun. To our eyes, it blazes with light. To our skin, it warms with heat. But beneath its surface, it rings like a bell. Waves of pressure ripple through its plasma, rising and falling, bouncing from its core to its surface. These oscillations create tones, not tones we could hear directly, but measurable frequencies nonetheless. The sun sings, a song of hydrogen fusion and magnetic storms. Instruments have recorded its notes, shifted them into audible range, and the result is eerie, a low, resonant hum, the voice of a star carrying across time. It sounds fake. It sounds like imagination. And yet it is real, a reminder that even silence hides vibration. Beyond the sun, planets themselves contribute to this cosmic symphony. Jupiter, with its immense magnetic field, interacts with the solar wind to produce radio waves that can be transformed into sound. When we convert these signals, we hear crackles and roars, like storms in an alien sky. Saturn, too, hums with radio emissions, rising and falling with its seasons. The giant planets are not mute spheres, but resonant instruments, their magnetic fields shaping sound from the charged particles of space. Deeper still, black holes, the very icons of silence, produce sound, not in the way we imagine, but in vibrations of space-time itself. In 2003, astronomers using NASA's Chandra X-ray Observatory discovered ripples in the gas surrounding a black hole in the Perseus cluster. These ripples corresponded to a note, a sound wave 36 octaves below middle C, a frequency so low it would take 10 million years for a single cycle. The deepest note ever detected in the universe, a sound that seems impossible, a tone too vast for human senses, yet written into the structure of the cosmos. And then there are the gravitational waves. Predicted by Einstein, confirmed a century later, they are ripples in space-time itself, created when massive objects accelerate. Two black holes spiraling together, two neutron stars colliding. These cataclysms send tremors across the universe. We cannot hear them with ears, but we can record them, translate them into sound. What we hear is a chirp, rising in pitch as the objects spiral faster, ending in a sudden silence as they merge. To think that space-time itself can sing, that the fabric of reality can vibrate, sounds like fiction. Yet it is real, captured by detectors like LIGO, allowing us to listen to the universe itself. Even the cosmic microwave background, the afterglow of the Big Bang, carries echoes of ancient sound. In the first 380,000 years of the universe, when matter and radiation were still coupled, pressure waves rippled through the hot plasma. These acoustic oscillations left imprints in the distribution of galaxies we see today. The universe itself once rang with primordial sound, a chorus of creation now frozen into the pattern of the cosmos. We cannot hear those ancient tones directly, but they are there, written into the structure of space. The truth is that silence in space is an illusion born of our limited senses. We cannot hear because our ears are made for air, not plasma, not space-time. But with instruments, we can translate. We can listen to the hum of the sun, the roar of Jupiter, the bass note of a black hole, the chirp of merging stars. We can hear the universe sing in registers beyond imagination. And perhaps the most haunting truth is this: the universe does not sing for us. It sings because physics demands it, because energy moves, because vibration is inevitable. We are accidental listeners, creatures who evolved on one small world and built tools capable of tuning into cosmic frequencies. Yet in listening, we discover that we are part of the symphony. Our atoms vibrate, our planet resonates, our very cells depend on waves of energy moving through space. The silence of space is only the silence of ears. In truth, the cosmos is alive with music. Not the music of human making, but the music of physics. Deep, strange, incomprehensible. It sounds fake. It sounds like metaphor. But it is fact. Written in waves, recorded in signals, audible if only we know how to listen. To sit in that silence, knowing it is full of hidden sound, is to realize that the universe is not mute. It is alive with voices. The stars sing. The planets hum. The black holes drone. The cosmos itself vibrates. And in its impossible music, we hear not silence, but the truth. Reality is stranger than we can imagine, and even in the void, there is always song. Stranger than fiction. If the universe has taught us anything, it is that reality outpaces imagination. Time and again, the discoveries of astronomy sound less like science and more like myth, less like equations and more like dreams. Clouds of alcohol larger than solar systems. Planets of diamond, worlds where it rains liquid metal or frozen methane. Even matter itself, the building blocks of the cosmos, can take forms so alien that our words strain to describe them. The facts sound fake. They sound like fiction, yet they are not. They are the true fabric of reality. Consider the vast molecular clouds where stars are born. They are cold, dark, and immense, stretching across hundreds of light years, incubators of suns and planets. In 1995, astronomers studying Sagittarius B2, a giant cloud near the center of our galaxy, discovered something extraordinary. It contained vast amounts of ethyl alcohol, enough to fill 400 trillion pints of beer. This was not beer in the sky, not drinkable spirits for cosmic travelers, but a chemical signature, the natural byproduct of reactions in interstellar space. Still, the image of in the Horsehead Nebula in Orion, scientists have detected complex organic molecules, building blocks of life scattered across space. Glycine, the simplest amino acid, has been found drifting among the stars. Space, it seems, is not sterile but fertile, a chemistry set on a galactic scale. If life on Earth arose from such molecules, it may not be unique. The seeds of biology are everywhere, scattered in clouds that glow and shimmer with potential. Then there are the planets of wealth beyond fantasy. We have already glimpsed 55 Cancri, a super-Earth rich in carbon that may be half diamond. Imagine a world where mountains of gemstone rise beneath alien skies, where continents glitter in crystalline light. The value is meaning there are no markets in space, no jewelers waiting to cut stones the size of mountains. But the fact is staggering. A diamond planet is not a dream. It is a reality, orbiting a star 40 light-years away. Other worlds rain metals. On WASP 121b, temperatures are so high that iron vaporizes in the upper atmosphere. There, iron condenses and falls as rain, droplets of molten metal streaking through alien skies. On Neptune and Uranus, the pressure in their deep atmospheres is so immense that carbon atoms may compress into diamond, falling as diamond rain. Imagine storms of jewels cascading into oceans of slush and ice. What poet could have invented such a vision? And yet here it is, a fact of physics. Even the stars themselves contain strangeness. Some white dwarfs, the remnants of stars like our sun, crystallize as they cool. Beneath their surfaces, carbon and oxygen freeze into crystalline lattices, forming spheres the size of Earth made of diamond. There may be billions of such stars in the galaxy, ancient, cooling diamonds floating in darkness, the corpses of suns transformed into jewels. They shine faintly, not with brilliance, but with memory, relics of stars long dead. Stranger still is matter itself, when pushed to extremes. In neutron stars, we see protons and electrons crushed into neutrons, forming matter denser than anything we can imagine. But deeper within, stranger states may exist, quark matter, where neutrons dissolve into their fundamental particles, a soup of quarks bound in exotic forms. Perhaps even stranger states of matter await, like strange quark matter, stable lumps of particles that could survive across the universe. To speak of such matter is to speak of things beyond experiment, beyond laboratory, matter stranger than any fiction, yet demanded by physics. The universe also holds illusions. In the Tress 2b exoplanet, blacker than coal, light itself is swallowed. Its atmosphere reflects less than 1% of starlight, making it darker than the darkest paint we can manufacture. A planet that absorbs nearly all light sounds like the invention of an artist of shadows. But it is real, a world of endless night orbiting a distant star. Even the elements themselves take on strange roles. Mercury, common in space, pools in alien craters. Helium forms oceans on gas giants. Hydrogen fuses into helium in stars, releasing the light that sustains us. But under pressure, hydrogen itself becomes metallic, conducting electricity, behaving like no substance we know on Earth. Metallic hydrogen may exist deep within Jupiter and Saturn, forming cores that drive their immense magnetic fields. To imagine a metal made of the simplest element, a substance forged only under pressures so high they defy our machines, is to glimpse the bizarre truth of physics. What is most astonishing is not that these things exist, but that they exist everywhere. Alcohol clouds drift across the Milky Way. Diamond planets circle nearby stars. Metal rain falls on distant worlds. Strange matter pulses within collapsed stars. The universe is not normal. It is outrageous, extravagant, inventive. It is a place where fiction is outpaced by reality, where the most unbelievable things are simply true. And perhaps that is the final lesson of facts stranger than fiction, that imagination is limited by what we know. But the universe is not. It builds storms of jewels, planets of shadow, stars of diamond, clouds of alcohol. It builds with laws of physics that permit extravagance. It is not restrained by what seems believable. To look at these facts is to realize that fiction is the child of reality, not its rival. The tales we tell, the myths we weave, the dreams we dream, they are echoes of a cosmos that is already stranger. To live in such a universe is to live in a story written by physics, one where every page holds something new, something impossible, something real. Invisible architects. The universe we see is not the universe that is. The stars, the galaxies, the glowing clouds of gas, all of it is only the surface, the visible tip of something far greater. Beneath it lies a hidden skeleton, a framework we cannot see, but which binds everything together. Without it, galaxies would fly apart, stars would scatter, and the universe as we know it could not exist. These are the invisible architects, dark matter and dark energy, two mysteries so vast they seem like fantasy. And yet they are real, proven not by sight, but by effect, sculptors of reality whose presence we feel in every corner of the cosmos. The first hint came not from grand discoveries, but from motion. In the 1970s, astronomer Vera Rubin studied galaxies, expecting stars at the edges to move more slowly than those near the center. But they did not. They moved just as fast, too fast for the visible mass of the galaxy to hold them. Something unseen was adding gravity, something invisible binding stars into orbit. This hidden mass became known as dark matter. Not dark because it is shadow, but because it does not interact with light. It neither glows nor reflects. It passes through space, through us, without a trace, except in gravity. Dark matter outweighs the visible universe 5 to 1. For every atom of star or planet or human body, there are 5 particles of something else, invisible and unknown. Entire halos of dark matter surround galaxies, invisible cocoons binding stars together. The Milky Way itself floats within such a halo, unseen but massive, its pull shaping the orbits of stars, guiding the motion of satellites, sculpting the arcs of galaxies across space. To imagine that most of the universe is invisible, that what we see is only a fraction, feels absurd. But it is true. Dark matter reveals itself in other ways. When galaxy clusters collide, the hot gas slows, lingers, and glows in X-rays, but the mass of the cluster, mapped by gravitational lensing, slides past unaffected. Matter we can see behaves one way. Matter we cannot see behaves another. The bullet cluster, 3.8 billion light-years away, shows this separation clearly. A cosmic crime scene where invisible fingerprints are laid bare. It is evidence that dark matter is not just illusion, not just a trick of physics, but something real, something with weight, something woven into the bones of the cosmos. Skeleton, dark energy is the breath. Stranger still, harder to grasp. In the 1990s, astronomers studying distant supernovae expected to find the universe slowing down, its expansion dragged by gravity. Instead, they found the opposite. The universe was accelerating, galaxies rushing apart faster and faster. Something unseen was driving this expansion, a force not of gravity, but of repulsion. They called it dark energy, though the name is as much confession as description. We do not know what it is, only that it exists, that it makes up nearly 70% of the cosmos, that it pushes galaxies apart with silent insistence. Dark energy fills space itself, not as substance, but as property, a pressure that grows as the universe grows. The more space there is, the more dark energy, the faster the expansion. It is runaway physics, a feedback loop written into reality. And its consequences are staggering. If it continues, galaxies will drift beyond sight, stars will burn out, matter itself may tear apart. The ultimate fate of the universe may be written not in fire, but in silence, in expansion, in the slow unweaving of everything into nothing. And yet, here we are, fragile beings of atoms, living in the minority share of reality. Less than 5% of the cosmos is made of the matter we know. Stars, planets, people. The rest is mystery. To say this aloud sounds fake, Like a punchline, 95% of the universe is invisible, unknowable, strange, and yet it is fact, supported by decades of evidence, measured in lensing, mapped in microwave background, traced in the motion of galaxies. The invisible architects are humbling. They remind us that what we see is not all there is, that vision is a shallow sense, blind to the deeper structure of reality. They remind us that the universe is built not only of light, but of shadow. They remind us that even in science, the majority of truth lies beyond reach, waiting in silence. Perhaps that is their greatest lesson. That reality is not confined to the visible, the tangible, the ordinary. It includes the hidden, the strange, the invisible. It includes architects we cannot see but must trust, forces we cannot touch but must accept. And in their mystery lies wonder. For if the cosmos were fully known, it would be smaller. Its vastness is not only in its stars, but in its secrets. Dark matter, dark energy, the skeleton and the breath of the universe. They sound fake. They sound like the inventions of dreamers. But they are real as the galaxies we see, as real as the stars above, as real as the breath we take. The universe is not made only of what shines. It is made of what hides, and in that hiddenness lies the truth, that the cosmos is larger, stranger, and more impossible than we will ever fully know. The universe as illusion. We trust our senses. Sight, sound, touch, taste, smell. They tell us what is real. A stone feels solid. A star looks bright. A clock measures time. But physics whispers a stranger truth. Reality is not as it seems. Beneath the surfaces we trust lie layers of illusion, patterns that disguise deeper structures, truths that sound like fantasy. The universe, in the end, may be less substance than appearance, less certainty than shadow. It may be, in ways, an illusion. Begin with solidity. To touch a rock is to feel something dense, immovable. But what is it really? A collection of atoms. Atoms themselves are mostly empty space, nuclei surrounded by electrons that never truly touch. The solidity we feel is the push of electromagnetic forces, repulsion at the subatomic level. The stone in your hand is not solid in the way it seems. It is mostly void, held together by forces invisible. You feel resistance, but you never touch. What feels undeniable is already illusion. The same is true of color. The red of Mars, the blue of Neptune, the white blaze of a star. None of these colors exist in the objects themselves. They are wavelengths of light, interpreted by eyes and brains, transformed into perception. Without a mind to see them, there is no red, no blue, no white. Only waves, only photons. The colors of the universe are not properties of things. They are illusions conjured within us. Time, too, which feels steady and universal, is illusion. Einstein showed that simultaneity is relative. There is no universal now. Time flows differently depending on speed, depending on gravity. What you call present is not the same as another's. What feels like unbreakable rhythm is instead a local effect of space-time, a convenience of perception. Time is not absolute. It is appearance, flexible, strange. Even the laws of physics hint at deeper illusions. The holographic principle, born of black hole physics, suggests that the three-dimensional world we experience may be a projection from information encoded on two-dimensional surfaces. In this view, reality is like a hologram. The depth we experience is emergent, not fundamental. Our universe, vast and deep, may in truth be written on a cosmic horizon, its richness unfolding from information stored at the edge. It sounds like science fiction, but it is serious physics, equations pointing to truth, stranger than perception. Quantum mechanics deepens the strangeness. Particles exist in superpositions until measured, probabilities collapsing into outcomes only when observed. The act of observation itself seems to participate in creating reality. Erase the measurement, and the past itself becomes uncertain. The solidity of the universe dissolves into wave functions, into chance and collapse, into outcomes that exist only when seen. Reality, at its core, is not fixed, but probabilistic, not solid, but shimmering, not certain, but contingent. And beyond physics lies the unsettling idea of simulation. If civilizations can create simulations indistinguishable from reality, and if such simulations multiply, then the probability grows that we ourselves are within one. The equations of physics, the digital nature of reality at its smallest scales, the pixel-like grain of space-time suggested by quantum gravity, all could be signatures of code, hints that the cosmos is computation. If so, then our stars, our galaxies, our histories are illusions within a larger machine. We would not know. We could not know. And yet, the possibility stands. But illusion does not mean false. It means deeper. The stone may be empty space, but it is real. The color may be perception, but it is real for us. Time may be relative, but it flows nonetheless. Illusion is not deception, but revelation. A reminder that reality is layered, that what we see is surface, that beneath the familiar lies the strange. Perhaps this is the ultimate lesson, that reality is not designed for our comfort. It is designed by physics, by mathematics, by truths indifferent to intuition. Our senses evolved for survival, not for truth. They tell us enough to live, not enough to know. Science peels back those illusions, revealing a cosmos stranger than we can imagine. The universe as illusion sounds fake. It sounds like dream, like fantasy. But it is real, measured, tested, hinted at in data, whispered in equations. Reality is not what it seems. It is deeper, stranger, more astonishing. We live in a hologram. We live in probability. We live in shadows of truths we cannot fully see. And yet, in those illusions, there is wonder. For if the cosmos is hologram, then we are its light. If reality is probability, then we are its outcomes. If the universe is simulation, then we are its players. Illusion or not, it is ours. Vast, beautiful, impossible. And it is real, precisely because it seems fake. When stars die, stars look eternal. To us, they seem fixed, their light unwavering, their presence unchanging across generations. But every star is mortal. They are born, they burn, and eventually they die. Their deaths, far from quiet, are among the most spectacular and violent events in the universe. They explode with energies that stagger the mind, outshine entire galaxies, and forge the elements of life itself. They collapse into corpses stranger than imagination, white dwarfs of crystal, neutron stars of infinite density, black holes that swallow time. The ways stars die sound fake, and yet they are real. A star's fate is written in its mass. Small stars, like our sun, live long lives, burning hydrogen slowly for billions of years. When the fuel runs out, they expand into red giants, their outer layers swelling until they engulf their inner planets. For Earth, this means doom in 5 billion years, the sun growing. Vast and bright, swallowing Mercury, Venus, and perhaps even our world. Yet the end is not fire alone. The giant sheds its layers in a slow exhalation, gas drifting outward, glowing in the light of the dying core. These planetary nebulae, despite the name, have nothing to do with planets. They are shells of beauty, bubbles of color, radiant in space. At their heart remains a white dwarf, a star's core compressed into a body the size of Earth, dense, faint, cooling over eons until it becomes a black dwarf, invisible in the dark. For more massive stars, the end is not gentle, but catastrophic. These giants burn fast, consuming fuel at furious rates. When the hydrogen and helium are gone, heavier elements ignite: carbon, oxygen, silicon, until iron forms in the core. But iron cannot fuse to release energy. It is the dead weight of physics. When the core fills with iron, fusion halts. Gravity, long held back, rushes inward. The star collapses in seconds. Its core implodes, rebounds, and the result is a supernova, an explosion so bright it can outshine a galaxy, so powerful it can be seen across the universe. In these moments of death, the universe is renewed. The heavy elements forged in the heart of stars are scattered across space: oxygen, carbon, gold, uranium. The iron in your blood, the calcium in your bones, the oxygen in your breath were made in such deaths. Every atom heavier than helium was born in a star and released in its death throes. To say we are stardust is not poetry. It is fact. Our very bodies are the ashes of dead stars. Some supernovae leave behind neutron stars, the densest matter outside black holes. Others collapse further still. If the star is massive enough, its death creates a black hole, an object of such gravity that nothing escapes. A place where death becomes a new kind of existence, where time itself is trapped. And then there are the hypernovae, even greater than supernovae. These are the deaths of the most massive stars, eruptions that release 10 times the energy of a supernova, blazing with unimaginable violence. They are rare, but when they occur, they mark the universe with their fury. Some hypernovae produce gamma ray bursts, the most powerful explosions we know. In seconds, they unleash more energy than our sun will release in its entire life. Focused in narrow beams, these bursts can travel across billions of light years, visible from the other side of the universe. Were one to strike Earth directly from a nearby star, it could strip our atmosphere and sterilize the planet. Thankfully, none so close are aligned with us. But the fact they exist at all sounds fake. How can a star release in moments what galaxies release in eons? And yet they do. Their light recorded by satellite, their afterglows studied by telescopes, their reality undeniable. Even stranger are pair instability supernovae, a rare type of explosion in the most massive stars. In these giants, gamma rays in the core transform into particles and antiparticles, destabilizing the star. The result is total destruction. No remnant, no neutron star, no black hole. The star is obliterated entirely, leaving only its light and its elements. A sun destroyed utterly, erased from existence, undone by its own physics. It sounds like myth, and yet it is real. The end of stars is not only destruction, but transformation. White dwarfs crystallize into spheres of diamond. Neutron stars sing as pulsars. Black holes open abysses in space-time. These corpses are not dead in the way we think of death. They are new states of matter, new kinds of existence, echoes of the stars they once were. The night sky is filled not only with stars alive, but with the remnants of stars long dead, their corpses invisible, their legacies radiant. When we look at the heavens, we see serenity, but beneath that serenity lies violence. Every atom of our world was once caught in a stellar furnace, every element forged in fire and scattered by explosion. The universe is built not by quiet, but by death. The end of stars is the beginning of worlds, the ashes of suns giving rise to planets, to life, to us. To imagine stars dying in such ways feels like fiction. Explosions brighter than galaxies, beams of radiation tearing across billions of light years, corpses denser than imagination. And yet, it is real. It is the truth of physics, the destiny of suns, the cycle of the cosmos. Stars die, but in their deaths, they give everything. The sky we see is not eternal. It is a graveyard and a nursery, a place of endings that are beginnings. Every star will die. Every galaxy will change. And in their deaths, new forms will rise. That is the strangest fact of all, that death is not end, but creation. The universe lives because stars die. The fate of everything. The universe is a story, and like all stories, it has a beginning, a middle, and an end. The beginning we know, the Big Bang, a flash of energy and expansion that set everything into motion. The middle is now, the age of stars and galaxies, the age of life and thought. But what of the end? What happens when the last star flickers out, when galaxies scatter, when the pulse of creation grows quiet? The fate of everything sounds like philosophy, like dream, like nightmare. And yet physics writes it in equations. Cosmology paints it in possibility. The end of the universe is not imagination. It is inevitability. There are several fates written into the cosmos, each depending on the rules of expansion, each stranger than fiction. The most chilling is heat death. In this scenario, the universe expands forever, galaxies rushing apart faster and faster, driven by dark energy. Stars exhaust their fuel. Black holes evaporate through Hawking radiation. Matter itself decays, protons dissolving after unimaginable stretches of time. What remains is cold and dark, a thin soup of particles spread across endless space. No energy left to drive change, no gradients left to sustain life. A universe in perfect equilibrium, absolute silence. It is called heat death, not because of fire, but because of its absence. No heat, no spark, no possibility. An end not in flame, but in cold. Another possibility is the Big Rip. If dark energy is not constant but grows stronger, then expansion will not only continue, it will accelerate without bound. Galaxies will first drift apart. Then stars within galaxies will be torn from one another. Then solar systems will be unbound. Eventually, even planets will be ripped apart. Atoms themselves torn as expansion overwhelms every bond. Space will not merely expand, it will devour, shredding everything until there is only chaos. The very fabric of space-time will split, the universe ending in violence unimaginable. A gentler vision is the Big Crunch, the mirror of the Big Bang. If gravity overcomes dark energy, expansion could halt and reverse. Galaxies would fall back together, stars collapsing inward, the universe heating as it shrinks. At the end, everything would converge into a singularity, all matter and energy compressed into a point of infinite density, a final echo of the beginning. From there, perhaps another bang, another birth, another cycle, an eternal rhythm of expansion and collapse, death and rebirth, cosmos without end. And then there's the most exotic vision, the Big Bounce. Some cosmologists suggest that the universe may not end at all, but transition. That space-time may have properties allowing contraction to rebound into expansion. That the death of one universe may be the birth of another. In this view, the cosmos is not a one-time event, but an eternal cycle, an infinite pulse. Our universe is not the story, but a chapter. Others came before, Others will come after. The strangest possibilities lie at the edges of theory. Some suggest that universes may bud from black holes, each collapse birthing new realities with different laws of physics. If so, then our cosmos is itself the child of another, our stars and galaxies the byproduct of some distant collapse. Others imagine that quantum fluctuations in the vacuum may spark new universes, bubbles inflating into new realms. The multiverse, infinite and strange, may mean that even if our universe ends, the whole never does. We are a bubble among bubbles, an echo among echoes, an illusion among infinities. All of these scenarios sound impossible. Galaxies torn apart, atoms ripped into pieces, universes reborn in endless cycles. And yet, they are not fantasy. They are physics, drawn from observation, from equations, from the same reasoning that predicted black holes, gravitational waves, and the expansion of the cosmos. They are theories of the end, grounded in the truth that nothing lasts forever. Not stars, not galaxies, not even universes. What does it mean to live in a cosmos destined for death? For us, fragile beings of brief lives, the scales of cosmic time are overwhelming. Whether the universe ends in cold, in collapse, or in rebirth, it will be trillions of years beyond our sight. We will not be there to witness it. Our species will vanish. Our planet will perish. Our sun will burn away long before. The end of the universe is not for us to see. It is for physics to whisper. And yet, knowing this end changes how we see the present. It reminds us that the age of stars, the age of life, is temporary. That to exist now, in the middle, is a gift. We live in the brief flicker between beginning and end, in the golden age of galaxies and suns. We live in the moment when the universe is alive with fire, when the night sky still glitters with stars. That is extraordinary. That is rare. In the eternity of silence before and after, we exist now. The fate of everything is written in possibilities. Heat death, big rip, big crunch, big bounce, multiverse. Each sounds impossible, absurd, fake, yet each is a door opened by physics, a glimpse into destinies beyond imagination. The universe may end in silence, or in fire, or in rebirth. We do not know which. We may never know, but we know this: the universe will not last, and in that impermanence lies meaning. For if everything ends, then everything now is precious. Every star, every planet, every breath. To live in a temporary cosmos is to live in wonder. The end does not diminish the universe. It makes it beautiful. And so we look to the stars, knowing they will die. We imagine the galaxies, knowing they will drift. We ask of the universe, knowing it will answer with silence. And yet, in that silence, there is truth. That even the most unbelievable fates are real. That the cosmos is vast, fragile, impossible. That the fate of everything is not to last, but to be, briefly, brilliantly, impossibly real.